Okay, so let's talk about handshaking, which is not what two people do, but is similar, which is why we call it handshaking. All right. Handshaking is a process where we're going to send a communication between two devices. We're going to send a signal back and forth. Okay, so we could do it with two systems that are alike, like two scorebots could handshake with one another, or we could do it with two systems that were not similar, all right, at all. So you could also do it with two systems that were completely not designed to work together, all right. And so these systems then could work together to accomplish a more difficult task, to increase their work envelopes if they were two robots. There are a variety of ways they could do that, all right. Let's also talk about one reason handshaking between very dissimilar systems may be required. A lot of times, guys, what happens is, for one reason or another, the primary vendor of an item will change. Say you used to buy all your equipment from vendor A. For whatever reason, things have changed now and you're buying it from vendor B. Okay? You're not going to go through your facility, your manufacturing facility, and throw out everything that vendor A made. So you've got to figure out how to make those disparate systems work together, how to handshake those two things together. All right? So handshaking is a very simple form of communication, and it's where you just send a signal from a robot to a machine, or a machine to a robot. All right, it could be between two robots, two machines. You could handshake together multiple systems. You could handshake together 5 or 6 different systems. All right, so this is a handshaking layout here between two robots, or they are working in conjunction to accomplish some kind of task. All right, communication. All right, so here's the key on communication. The signal this piece of equipment, the smiley face, is sending has to be received. Okay, so this is this piece of equipment's output. All right, and it becomes the other piece's input. All right, so remember that while it's an output to one piece of equipment, it becomes an input to the other. All right, okay, so you could use something like this to tell you when part feeders are empty. This system shows a part feeder, a robot on a slide base, and a milling operation. All right, so all 3 of these things could be communicating together. All right, the part feeder is only going to have outputs. Okay, it's only going to send signals. It doesn't have an input. There's nothing else to do. Okay, however, the robot and the milling machine will both be using inputs and outputs from each other. All right, for instance, the robot may tell the mill, I've loaded the part, I'm out of the way. Okay, that's an output signal from the robot, an input to the mill. The mill could also then send a signal that says, I am done milling the part, you can come get it. So that would be an output from the mill and an input to the robot. All right, okay. When two machines talk, the signals have to be isolated, all right? And we can use things like optical isolators and relays to improve that situation. All right, just going to go over briefly what a relay is. A relay contains a coil of wire on the input side, A and B. All right, see here? All right, and power is sent through that coil and it makes a magnetic field. All right, when that happens, it causes a connection between C and D. So C and D is a normally open switch that changes to normally closed when power is sent through A and B. Okay, resistors. Sometimes you may need to use a resistor to convert your signal. All right, you could also use it to limit the amount of current to another component like an optical isolator. All right. So those components will have to be determined. All right. Okay, the other thing is you may have to build a simple circuit using a breadboard. Okay, a breadboard's just a tool you can use to create a simple circuit without soldering. Okay, and we want to keep the wires short and use as few wires as possible. All right, so this might be an example of Fisher techniques communicating with each other. All right, this would be like a carrier system here, and this one appears to be like a milling operation. Okay, so they are communicating with one another, right? And so you guys will be handshaking together the Fisher techniques. All right. Okay, so when you do Fisher techniques to Fisher techniques, it's generally helpful a lot of times to have a relay to do that. Okay, so this is what that looks like, and it is one way to do it. All right. And here's a electrical schematic of what's happening. All right, remember I told you when we energize the pins A and B, and that's the black and the yellow on the 5-volt side, okay, then it can close C and D. That's the yellow in the center on the 5-volt side, and the black closer to the ohm symbol, okay, and it becomes the input.